review, solving compound inequalities. So compound inequalities are when two or more inequalities are joined together by either the word and or the word or. So if they are and compound inequalities, there's two ways we can write them. We can either write them as a giant inequality, so a low number less than the variable less than the high number. And the way this is read is 2 is less than x and x is less than or equal to 9. So you use the middle portion twice. Or we can write them as separate inequalities and put the word and in the middle. The big idea about and is that it has to make each section of the inequality true. So for example, if I try this, if I substitute a 12 in for x, 2 is less than 12, but unfortunately 12 is not less than or equal to 9. So that means 12 would not work as a solution. And if I look at my graphical example here, 12 falls outside of this shaded area, which also shows that it's not a solution. So for and inequalities, the solution area is between the boundary points. The other type is an or. So for or inequalities, that means I can be a solution to one of them or both of them, but I have to be a solution somewhere. So the way this is read, this is always written in two separate inequalities separated by the word or. Is x less than 2 or x greater than or equal to 9? So for example, if I picked the number 0, that is in fact a solution. One, because it's in the shaded area. Also because if I try it out here, 0 is less than 2, so it doesn't have to be a solution for both. If I try 4, for example, 4 is not less than 2, and 4 is not greater than or equal to 9. So since it didn't work in either of them, 4 is not a solution. In this case, the solution areas are outside the boundary points. Now, some of the graphs don't actually show arrows, but this shade actually goes on forever left and forever right. So sometimes they won't show the arrows. They are understood to be there. So example 1, solve each compound inequality, then graph on a number line. So this is one of the ands because it has two inequality symbols. There's one inequality here and there's another one here. So the way that we solve these is we're going to pretend that this left side does not exist for a minute, and we're just going to solve this like we normally would. If I want m alone, that means that I'm going to have to add 4 to both sides. But I don't only have a right side, I also have a left side. So since I added 4 to the middle and the right, I'm going to have to add 4 to the left. So you're doing it 3 times. It's like you have 2 walls instead of only having 1. So the 4 in the middle goes to 0, which is what I wanted. So now m is alone in the middle. On the left, -3 plus 4 makes 1, less than or equal to. -1 plus 4 makes 3, and that symbol is a less than. So now that m is alone in the middle, we have our solution. 1 less than or equal to m less than 3. So this is the algebraic solution. Let's talk about the graphical solution. So I'm going to graph my number line. Here's 0, 1, 2, and 3. So we have to talk about our boundary numbers. So the first boundary number that I have is 1, and that's going to have a closed circle. So I'm going to have a closed circle on 1. Then I have 3 as a boundary, and that's going to have an open circle. Since this is an and, our m, our solution, is everything in the center of 1 and 3. So now we have the algebraic, and we have the graphical representation of the solution set. Example 2, 3t plus 2 less than -7, or -4t plus 5 less than 1. So I see this or here in the middle. What that means is we're just going to solve both of these inequalities separately. So here's my little cover. So what we're going to do is we're going to pretend that this right-hand inequality right now does not exist, and we're going to go solve the left one like we would a normal inequality. So that means I'm going to have to subtract 2, 3t less than -9, divide by 3, t less than -3. So there's part of my solution. Now I have to solve the right-hand one. So we're going to have to subtract 5, negative 4t less than negative 4, divide by negative 4. And now, again, since we divided by a negative, that inequality flips. So it's going to end up being a greater than 1. And there's the other half of my inequality. So writing an or is simple. It's the first one or the second one. So there's the algebraic version. So now let's graph. So I have 0, 1, negative 1, negative 2, negative 3. So I need my boundary points. So the first boundary point I have is this negative 3. Since it's just a less than, that means it's going to be an open circle on negative 3. And if I want t less than negative 3, that means I want to shade everything to the left of negative 3. The other boundary line that I have is this 1, so that's going to be here. It is also an open circle because it's just greater than. And if I want all the numbers greater than 1, I'm going to shade to the right. So we have our algebraic and our graphic. Okay, so I have 4y plus 2 over 5 minus 5 greater than 3, or 4 minus 3y over 6 greater than 4. So I have a or inequality again, so that means we're going to ignore this right-hand side one for just a minute, and we're going to solve the left. So the first step in solving the left is we're going to add 5 to both sides. So we have 4y plus 2 all over 5 greater than 8. Now I can't get to the numerator until I get rid of the denominator. So we're going to have to multiply by 5 to get rid of that denominator. So we have 4y plus 2 greater than 40. So now we're going to have to subtract 2 from both sides. 4y greater than 38. And then divide by 4. So y is greater than 38 over 4. Doesn't divide evenly, but I can simplify it into 19 over 2. So there's half of our solution. So now we're going to actually go back to this other one that we covered and solve this one. So I don't have addition or subtraction, so I need to get rid of that division by 6. So we're going to multiply by 6 on both sides to get rid of it. So we have 4 minus 3y greater than 24. We're going to have to get rid of the addition by 4 by subtracting 4. Negative 3y greater than 20. And then I need to undo the negative 3, so I'm going to divide. Since I'm dividing by a negative, that means my inequality flips, and negative 20 over 3 does not simplify. So algebraically, my solution set is y greater than 19 over 2, or y less than negative 20 over 3. Now let's graph it. For a number line, decimals are easier to graph than fractions. So 19 over 2 is really 9.5. And then negative 20 over 3 is about 6.6 negative repeating. So it's a repeating decimal, but we can estimate. So I don't actually have to make 10 tick marks. As long as everything is labeled, it's accurate. So I can actually come over here and put a 9 and put a 10, and that's going to be the end of it. So when I want to use this boundary point as 9.5, it's going to be somewhere here, and it's an open circle because it's just greater than. So if I want greater than 9.5, that's going to be everything to the right. So same thing on the other side. I can make negative 6 and I can make negative 7. So negative 6.6 is somewhere here. It's going to be an open circle because of just the less than. And if it's less than, that means I want everything to the left. Example 14. So we have another and inequality. So I got two inequalities stuck together, so we're going to solve it all at once. So again, we're going to pretend that this side doesn't exist for a minute. And we're going to solve like normal. So I'm going to add 4 to both sides. That would be my first step. but since I added 4 to the right, I need to also add 4 to the left. So I have negative 10 less than or equal to negative 5w less than 5. Again, cover up the left. We're going to pretend that it doesn't exist. So negative 5w less than 5. My next step would be to divide by negative 5, which means I have to divide by negative 5 on everything, even the left. Now, just because there's 3 or 2 inequalities doesn't mean your rules change. Because you divided by the negative, all inequalities will flip, even if there's more than one. So negative 10 over negative 5 is a 2. This inequality is going to become a greater than or equal to w in the middle. This inequality changes to a greater than, and 5 over negative 5 makes negative 1. Now, yes, w is alone, it's isolated, so we're halfway done. We don't like them written this way, though. Most of the time, we like things written least to greatest. And right now, this is the other way around. It's greatest to least. So the smallest number we have is negative 1. Now, basically, it means we're reading the inequality this way. So if I read the inequality from right to left, this symbol is actually a less than. If you notice, the point is closest to the negative, the point is closest to the negative. Then we have w in the middle. I'm going to keep reading this way. So again, the point on this symbol has to be closest to w. So the point has to be closest to w. And then we have a 2. So this is the correct format for an and inequality. It's always written least to greatest. Now for our graph. So we have a negative 1 as a boundary and we have 2 as a boundary. So now negative 1 is just a less than, so it's an open circle. 2 is a less than or equal to, so it's a closed circle. And ands are always shaded here in the middle. Last inequality. So this looks crazy complicated, and the reason it looks crazy complicated is because there's a b in the left, b in the middle, and a b on the right. So when you have a variable in all 3 sections here, or even 2 sections, you're going to have to split this inequality into 2 smaller ones in order to solve this. So the first inequality is the left side and the middle side. This is the first inequality you're going to solve. The second inequality is the middle and the right. So you're using the middle twice, which happens anyway. So let's look at the first one. So I'm going to have the left side, 4b plus 18, and the middle, negative 12b minus 14. So let's work on solving this first. So I'm going to move my variables to the left. So we have 16b plus 18 less than or equal to negative 14. Subtract 18 from both sides. So we have 16b less than or equal to negative 32. Divide by 16. We're dividing by a positive number, so the inequality will stay the same. And then negative 32 over 16 makes negative 2. So here's half my answer so far, so let's hang on to that. Now the second inequality was the middle, so negative 12b minus 14 less than or equal to, and the right. Now let's solve this one. So move all my variables to the left, so add 5b to both sides. So that makes negative 7b minus 14 less than or equal to 14. Add 14 to both sides, negative 7b less than or equal to 28. Divide by negative 7. Since we're dividing by a negative, that inequality flips, and we end up with b greater than or equal to negative 4. This is the other half of my inequality. Now, since we split this apart, I'm going to graph it first before I do my algebraic solution, because graphs are a little easier to see. So let's put 0 on the right since I have 2 negative numbers. So I need negative 2 and I need negative 4. Those are my boundaries. So on the negative 2, I have a solid. On the negative 4, it's also solid. So for -2, I want all the numbers that are less than -2. So that means I'm going to shade left. Then for the -4, I want all the numbers greater than -4. So I'm going to shade to the right. So if you notice, right here in the middle is where my shades are overlapping. That's where my colors overlap. So that's where your actual solution set is here in the middle. So if we're going to write this algebraically, I have -4 on the left, less than or equal to, because it's solid, x less than or equal to -2. So graphical and algebraic. So number 6, write the inequality that is represented by the solution set shown on the number line below. So now I'm just trying to write this in an algebraic form. So my first step, I'm going to look for my boundary numbers. So the first boundary number I see is -4, and then I also see a 2. The second thing I need to see as well, is it a combined inequality or is it two separate? So since these are two separate, that means that I'm going to have that or inequality. So I'm going to have two inequalities separated by the word or. So the first inequality comes from this left-hand side. So it's going to be x and a -4, because that's the boundary number. And since the shade is to the left, that means it was less than or equal to. The equal to comes because it's a solid dot. Then the other part of the inequality solution is the right-hand side. So we're going to have x and a 2. Since it's shaded to the right, it's going to be greater than. And because it's an open circle, it's just a strict greater than. When you put or in the middle, there is your solution. So example 7, write the inequality that is represented by the solution set shown below. So same idea. So first things first, find your boundary numbers. So the first boundary number I have is a 4, and then a 9. Now I have to see, is it one inequality or is it two separate? So since this is one single shade, I know it has to be an and. So that means it has to be like number less than x less than number. That's your general format of an and. So the 4 is your first number because that's the smallest. It's an open circle, so it needs to be a less than. X in the middle, because that's where the solution set is, in the middle. Then 9 is the next number on the right, but since it's a solid, it's going to be less than or equal to. And there's the algebraic representation.